Welcome to episode 55 of Fresh Thinking by Snowden Optiro. My name's Ian Glacken. I'm an executive consultant at Snowden Optiro here in Perth, Western Australia. This is the second of a two-part discussion on the applications of conditional simulation. And today I'm joined by, again, Dr Oscar Rondon. Dr Oscar is the principal geostatistician with Snowden Optiro. When Oscar goes to Peru, they call him Don Oscar because he's such an important guy. But Oscar works very hard. Sorry.
Yeah, there you go.
As we mentioned in the previous podcast, Oscar is very strongly qualified in geostatistics and mathematics, and he's part of the Supervisor team along with Anthony Cook, and he provides very important advice on geostatistics to our group of consultants or advisors. So as I mentioned, this is the second part of a discussion on the applications of conditional simulation. So one of the things we talked about in the first episode, which was episode 54, we talked about this idea of using conditional simulation for resource classification. Now, Oscar, I know you wanted to say something on that.
Yeah, look, at the end of the podcast, you mentioned that we can use simulation for classification, right? And you use the 1915 approach.
Yep.
Yeah, I just would like to add a comment that when you classify your resources using conditional simulation and you assign measure, indicator, or infer based on conditional simulation, those categories are not the your code or the categories that we use in the your code. So we need to be really careful. There is a nice approach, it's a nice workflow using conditional simulation, but for instance, a key point when classifying resources is geological continuity.
Yeah, that's right, Oscar. Sorry, I should have said that. So the simulation is basically takes you part of the way. It gives you some variability, but as Oscar mentioned, I should have mentioned, the geologist or the competent person or the qualified person needs to consider things like the quality of the geological data, the quality of the data, the structural information, and they have to be considered as part of the classification. So yes, quite right. The simulation is not the be-all and end-all of the classification process. It takes you most of the way there, but then you do need to consider all of those other modifying factors, which is why we still have in the JORC code, and we will have, for time immemorial, we will have this concept of a competent person. The competent person or persons, these are the people that actually sign off on this. So they need to consider not just the simulation, but also geology, grade, and data quality and things like that. So I just wanted to make that quite clear because I didn't give you that impression. So in this second episode, we're going to talk about a different application. In the first episode, we talked about taking a group of simulations or realizations, as we call them, and all of the things that you can do with them. And I would say, based on my experience, that maybe 70 or 80% of the applications of simulation consider the suite of realizations. Now, what we're going to talk about in this second episode is this idea where we choose a single realization. In other words, if we generate 50 or 60 realizations, we're choosing a single one. So Oscar, what sort of things can we use this for broadly?
Yeah, so once you select a simulation, there are different criteria. We need to be really careful when selecting only one of the possible outcomes. But there are special cases where we can select one simulation. One application can be drill spacing analysis, which is really nice. So you have your simulation and you can sample the simulation at different drill spacing. And then you have, I mentioned before, transfer function or criteria that you can use to relate the drill spacing, right, to those criteria. For instance, you can try to minimize dilution, right? So you want to check what drill spacing you need to minimize dilution, right, or to minimize all loss. So there are different criteria that once you have a simulation, you can use.
Yep, that's about it. So I would say that the key operation here is to use the relatively sparse data to simulate, as Oscar mentioned, and to generate a series of realizations. And then, as Oscar mentioned, you need to choose just one, and that one needs to reflect the input data. Now, how do you check that? Well, you might check it visually, you might check it using the histogram, you might check it using the variogram. And the idea is that, of course, this simulation is generated at a much more dense spacing than the actual data. And as Oscar mentioned, the key application here is that once we have this dense realization, we can actually use that to resample. So we're actually generating pseudo drill holes. And the idea is that, as Oscar mentioned, we decide on what we want to do, and we generate multiple sets of pseudo drill holes, typically at different grade spacings, and then we would do something with those drill holes. So we might estimate with those drill holes, we might actually re-simulate, gets a bit complicated, but we might actually re-simulate with these drill holes, or we might apply a NSR formula. NSR stands for net smelter return. So this is the idea of the cost in multiple variables. So the idea of this is we're choosing a realization, and that's a key process. We're choosing the realization that matches the original data. Now, one of the key assumptions here is that because we're generating dense data, for instance, we might have original data at, say, 50 by 50 spacing, and we're generating data at 10 by 10. So one of the implicit assumptions here is that the variogram is going to be the same when we infill the data. Because what we're doing effectively is we're drilling the data without drilling the holes. Obviously, there's no such thing as a free lunch here. You don't get something for nothing. But if you've got a good match between the original data, the simulated data and your original data, then you would feel fairly well justified in taking multiple sets of pseudo drill holes and actually then doing something with that data.
Yeah, and I mentioned before that it's important to understand what to do or what you want to do with the simulation before running the simulations. We need to keep in mind, for instance, that if we have one simulation, what we are trying to have is variability. We want to reproduce the variability that the data has. That may explain why we want one simulation to capture that variability, sample the pseudo drill holes, and as you mentioned, and get some numbers, right?
Yeah, so if you're not comfortable with that, and this is something that we've done, you might want to take, say, 3 realizations. You might want to take a P5, which is like the 5th percentile of the distribution of the simulations, the P50, which is the median, and you might want to take the P95. And then whatever you do with these drill holes, you can then do it 3 times. And the idea is that if you do have quite a difference between the P5 and the P95, then you're sort of capturing, again, what I mentioned in the previous podcast, which is this idea of the space of uncertainty. So if you're not comfortable with choosing a single realization, then that's what you can do. Now, we as a consulting or advisory group in Snowden Optiro, we found this is a very popular set of applications, and we've generated quite a few case studies over the last 3 or 4 years. So I might just talk about one, and then maybe Oscar can mention some as well. One that we did was for a large copper nickel deposit, and the client wanted to know what the grade control spacing should be. So we generated a multiple realizations, and in this case it was a bivariate realization. In other words, we're simulating both copper and nickel, and we checked that the simulation or the realizations honored both the copper grade, the copper histogram, the nickel histogram, and the bivariate relationship between the copper and the nickel. So we generated a realization, and then we resampled it. We sampled it at a number of drill hole grids, 5 by 5 up to 20 by 20 or 25 by 25. Then what we did, we generated ordinary Krieg models, so just simple grade control models based on this data, and again, assuming that the variogram is the same. Then essentially what we were able to do was to look at the costs and the revenues of this process. The costs being, of course, the drilling. That's one of the main costs, the cost of the drilling. But the revenue comes from the areas where we classify ore, and we can compare it back to the truth, let's call it that. Right. And if we've got ore in our estimation and it's actually ore in the truth, the simulation, then we get a revenue from that. If we have ore in our model, and then we only have waste in the simulation, then we've got a misclassification. So what we can do is we can balance the misclassification. And there's 2 quadrants. One is ore mined as waste, and the other one is waste mined as ore. And we can balance that with the revenue. And of course, we need to consider the drill hole spacing. And we presented papers on this, and I can present those if needs be. But the idea of this is that we're generating a simulation or simulations. We're sampling them. We're generating grade control models, and then we're looking at the revenue from these grade control models. Oscar, do you have any other examples of case studies?
I was about to mention, Ian, that you were very lucky with that case study, because at that time you already have the multivariate simulation component in Supervisor.
Thank
right?
you very
Well,
much.
the project I would like to mention is a project that I ran with Anthony Cook and other people here at Snowden Optiro. At that time, we didn't have the multivariate simulation component ready. So we were given a big problem. It was to run a drill spacing analysis for an iron ore deposit. And because we have all this relationship between the different attributes, we had to use multivariate simulation component. It was a must. At that time, we ran all this conditional simulation, manual handling of all the files, and we put together a great case study. After that, we got the multivariate simulation component in Supervisor, which is great.
Yes, I'm very grateful. And when I did that case study, we actually weren't part of Snowden Optiro, so we were using it as a client. But Oscar was at Snowden, we were at Optiro, and Oscar was very helpful in getting us to debug, and it works fine. So those of you wanting to do multivariate simulation, there's two algorithms. This is the topic of another podcast, but the idea of multivariate simulation, in other words, you're preserving the original histogram of one variable or two or three or four or five, and you're also preserving the relationships between those variables. And for many years, that's been the holy grail of simulation.
Yep, correct. Yeah.
So we've got that, and we've got these applications for drill hole spacing. So if you would like to understand what we can do with that, there's some papers on this written by Oscar and Anthony, and also written by myself, presented at recent conferences, or just give us a call and we can discuss it. Yeah, so that discussion brings to a close our second podcast on the applications of conditional simulation, focusing specifically on the idea of sampling or resampling a particular simulation. If you like that, please subscribe to the Snowden Optiro YouTube channel. Go to the Fresh Thinking by Optiro portion of the Snowden Optiro website, or go to Spotify, Apple Podcasts, Google Podcasts, or wherever good podcasts are found. So thank you, Oscar.
Thank you, Ian.